Go.
Okay. Our topic is about the joint stereo matching and semantic segmentation with CNN. First, we have a brief introduction about the stereo matching and semantic segmentation. The basic idea of stereo matching is to make use of the two image, left image and right image. For one single object, it will have different pixel on different images, and you can see we can find the pixel shift of the same object and use the pixel shift to compute the depth of that point. And for semantic segmentation, you can see that the input is the RGB image and the output is a matrix of different labels. For the same object of same kind of object, it will have the same label. For example, those cars. Our task is to join these two tasks together. So at first we do a very simple experiment on a small synthetic human figure data set. And you can see here are two images. The left one is the output of segmentation only, and the right image is the output of the network with both segmentation and the disparity. Disparity is the stereo matching. And we find that it is obviously that the contour of the human figure is quite it improves a lot for the multitask. So in this experiment we test our idea, and later we use another data set.
Then we change to the cityscape dataset to do our experiment on a real dataset which based on the urban sense understanding, which it has have 19 classes. And about our model, we construct our model based on the flow net. The structure of our network is the encoder part and the decoder part. In the encoder part is our inputs are right image and left image. Then we do the convolution to downsample the features. The correlation layer do the combination of the left and right image with in the convolution way. And after the encoder, we divided the features into two tasks about the segmentation and disparity. They learn the features disparately and we get our result after the loss.
And this is our basic model. And we want to get a higher performance on segmentation, so we try different training algorithms in our experiments. First are the two different algorithms for especially for multitask training. About alpha layer.
The alpha layer is just a linear combination between the disparity feature and the segmentation feature. You can see from the left of the algorithm, it can calculate the parameter of alpha automatically by the backpropagation. And the right part is just the structure of the input feature text A and text B, and the shared feature will be calculated and output the shared text A and the shared text B.
Okay, next about the joint loss layer. The idea of joint loss layer is to join the different loss together to get to minimize the sum. And for the in the paper, the researchers think that the output follows the Gaussian distribution, and they then compute such formula to minimize the total loss. And the new here is the coefficient of different tasks and for different tasks, and it can also be automatically updated through the backward propagation. And this works for their network and gain great achievement, get great improvement. And later, we modified the data set because it only provides 3,000 training image pairs. So we want to enlarge the data set. One is balancing the data set, and another is cropping origin image. And for balancing, because we find that some classes have low percentage of all the images, so we just double or triple the images with low percentage to see whether it works. And for cropping the origin image,
about the cropping origin image, limited by the GPU memory, we have to and we want to get the high score, so we crop the image randomly for each image. We randomly crop the image into 8 to 16 crop images, and we get the final result perfectly.
And the rest part of the algorithm are some traditional segmentation network training tricks, and we use them on our network in our experiments. And let's go to the results part. And our experiment actually is divided into two parts. In my part, we resize the original image into smaller images to have better training speed and efficiency, so we can test more different settings. Here I show the results of different settings, and we find that for joint loss layer, it does not perform well because the network are totally different from the network provided by the data by that paper. And also we find balancing is quite useful, and it improved the final result. And later we use those settings on the cropping image on the original resolution.
This result just shows the comparison between only the segmentation model and our segmentation with disparity model. We can see that for each class, all the class can get the improvement of, and in average it's about 6.5%. And in a very low part, just some like the war, it got the 7% increase.
Okay.
And
In conclusion, in this experiment, we start from a typical stereo matching network, which is the FlowNet, and to do the multitask learning. And it is possible that we cannot get a higher score on the segmentation. The 65% is quite low on the benchmark. So later we will do our experiment on the pyramid scheme phrasing network, which is the current state of the art, and we will do the similar experiment on that network. And that is our future work. And that's the end.
thank you.